I like doing kind of interactive workshops like this. Like you're here spending time, you can, learn as much as possible, I hope. All right, hit record because I often forget. Again, setup, just sign up at the link I put in the chat, and you just need a modern web browser or something like Google Chrome. What this workshop is, so it's just an introduction to data annotation and using some AI-powered labeling tools to make it faster to label data for computer vision. And we're going to cover how to do this for object detection, instance segmentation, feature points, and classification. Again, ask questions as we go, and I'll be hanging out afterwards for more. And I'm just going to quickly walk through kind of what all these are. So if you haven't done them before either, you'll hopefully learn a little bit about computer vision and then how to make data sets for those problems. A little bit about me. I'm Sage Elliott. I'm a developer evangelist at Sixgill, sixgill.com. We do really, really cool stuff with machine learning, computer vision, and IoT, and kind of connecting all those things together. And we're making tools to make it easier for everyone else to do those things as well. For about the past 10 years, I've worked as a software engineer or hardware engineer with startups and agencies around Seattle, Washington, and then Melbourne, Florida. I always put that in there because quite often there actually is someone who at least lived in Melbourne, Florida at some point, and that's always fun to hear about it. I love making things with technology. You can connect with me at sageelliott.com. It has links to everything. Sage Codes on Twitter, and then LinkedIn. I'm Sage Elliott, 2 L's and 2 T's. You should be able to find me on there. And it's a good place to connect with me and ask any questions you might have in the future. So if you are labeling your own data set or trying to train a model, you can connect with me and send me a message there. A little bit about you. So I know some people already posted in there, but I saw quite a few more people join, and they haven't put in any text in the chat yet. So it's really fun to do a quick intro if you want. Let us know why you're interested in labeling data for computer vision. If you have any specific use case that you're working on right now, that's always really, really cool to hear. And then also, I'm going to put this link in here. It is a link to a Slack channel, which is also a great place to stay connected and ask questions. So a lot of people after workshops kind of will come in there, and then they're labeling their own data set, and they might have some specific problem with it. So it's a good place to stay connected. There's also an intro channel. You could introduce yourself in there. I miss doing events in person, actually meeting people. Oh, and then also, if you're going to put anything in the chat, and another question too, would anyone be interested in kind of like a casual happy hour type of event where you could actually, come in and just actually hang out and talk to each other? Let me know in the chat. Someone's got to do an intro, at least one person. I know sometimes people are quiet. That's okay too. Does anyone want to do a quick intro? I'll give you all a minute in case you're typing it up. I was just saying, if you want to do a super quick intro, like if you have any specific application of computer vision you're working on, or a use case, or maybe data that you want to label, like if you're working in a factory and you're trying to find anomalies on a conveyor belt or damage on any products or anything like that. It's always fun kind of hearing about the different use cases that people are coming from. Working on computer vision, monitoring a construction site. That's awesome. There's a lot of different stuff you can do in there. I don't know what you're specifically measuring, or if you want to let us know, you can. But if you don't want to give away all the secrets, you can. I was just going to say safety and PPV monitoring is a common one. So like you might be labeling for like hard hats or safety vests, right? And making sure that workers are compliant while they're in at least dangerous zones. Thank you for sharing your use case, because no one else did. A repeat just for anyone who came in, because people always join a little bit later. This is the link to sign up. We're going to be using this data annotation tool. And then the concepts too, we're going to cover, they can transfer over to other tools. So why do you need labels for computer vision? So computer vision isn't always necessarily tied with deep learning, but most of the applications are today that you see talked about, or use cases you're working on are probably using deep learning behind the scenes. And in order to get a well-trained computer vision deep learning model, you typically need to pass it data with labels saying, what certain things are. And we'll talk about that in a second. But essentially, right, you have like a function. You could think of it as a mathematical function or a programming function, and you're going to feed it training data with labels. It is going to learn from that, make predictions, look at those ground truth labels you gave it, and then adjust the deep learning neural network. And then hopefully you'd give it a new piece of data, and then it would make the correct prediction. So object detection, we'll talk about this today, where you're actually localizing and classifying where objects are inside images or videos. So in this case, here's an example of running an object detector I made on geese, and it's drawing a box around exactly where the goose is and then giving some sort of confidence level on it, for the class. So not only is it saying, hey, I think there's a goose in this image, it's actually saying, I think there's a goose and it's right here. And in this case, there's another goose and it's right here. And to label for that, you use something called rectangles or bounding boxes, and you just kind of draw bounding boxes around the objects you want to classify. And then you feed this into your deep learning model, and it'll kind of learn what you're looking for within these boxes. It's also cool because you can get counts, you can do all sorts of things when you have a good object detection model. Instant segmentation. So this is something where you kind of use something called polygons or a mask, and you're actually drawing more specifically around pixels of the image or of the object you're trying to classify. So this might be a little small here, but you can see that this bottle is colored red, and then there's water inside that's colored blue. And so these were labeled with polygons around the water and where the bottle is here. And then with instant segmentation, it's, you can actually do things based on like pixel interaction. So in this case, since we're measuring water and we're measuring where a bottle is, you could actually measure the bottle fill with kind of like a volumetric calculation of like how many pixels, within the bottle are labeled as water now, and do a calculation to get the level, which is pretty cool. And then also, like, if you're measuring interaction between, let's say, like individual fingers and a virtual keyboard, which is something a lot of virtual reality startups or systems are working on. Like if you've ever used the newer Oculus set, where it can see your fingers just with computer vision, and it's trying to understand exactly where a finger is and then what it's interacting with in a virtual space, which is really interesting, versus the object detection, which would have a harder time of drawing like a square around the entire hand. We wouldn't actually see just individual fingers and like interacting with small things like keys in this case. Yeah, feature point clustering. So this is used a lot in pose estimation, like body poses, kind of relation of points to other points. It's also used a lot in facial applications, like understanding the mood or expression someone is making. And you label this kind of putting dots in a specific order. And then when you feed this into your neural network, it kind of tries to make predictions of where these points are. And so in this case, you can see it's doing pose prediction on these people doing yoga. And when they go from one pose to another, it actually returns a different classification. So you can kind of measure the relation between all these different points, which is really cool. It's also used a lot kind of in the VR example I was saying, right? Like if you're looking at hands and seeing where they are posed. So maybe it's not interaction with something in the virtual space like keys, but it's like looking for a pinching movement or something, which is a common thing to do control in VR or AR. It might actually be doing pose estimation on fingers and then seeing when a thumb and finger meet or when they don't, or how far away they are. Like maybe you're doing a zoom. Classification. So classification is, typically you feed a whole image or a cropped portion of an image, and then you get a returned class back. So in this case, I trained a classification algorithm to look at dog breeds, and I fit at this one, said it was a Labrador Retriever. But if I had a Chihuahua in the back and the Labrador Retriever was more prominent, it would probably still predict Labrador. And it wouldn't know there's another dog back there. And that's why like object detection is used a lot, because it's a little bit more powerful of understanding what's in different parts of the image. But if you're doing cropping, or you do just care about what's in an image from kind of a whole level, classification can work very well. Here's an example. Labeling these, you really just put them in different folders or assign a class in some way to them, saying, in this case, it would have said this was a Labrador retriever, and then I would feed this into my model. And here's an example of multi-classification where it has two classes tied to it, where it says it's a painting and then also belongs to the Van Gogh family. So that's like a super brief intro of the different data types. Does anyone have any questions before we actually get into the labeling examples? Did any of those like make sense to you, or where you're like, that's what I'm looking for? I think image segmentation or instant segmentation might solve my problem, or do you think I feature points? Let me know in the chat. And again, so we're going to hop into Labeler in a second. So I'm going to share this link again in case people did not sign up and they want to. Which one of these kind of techniques sounds the most interesting to you, or maybe the most useful to anything you've been thinking about? And these aren't there are more computer vision labeling techniques, but these are kind of the most common four. Anyone? You don't have to, it's fine. But if you do have a use case, it's always cool to hear. Someone said point clustering and instant segmentation. Awesome. And very cool. Someone said Polygon labeling is a bit new. Would love to learn more. Well, you're in the right place because we're going to do Polygon labeling today. And I think you were the person who's doing the construction zone one, right? So you could totally use Polygon labeling around like safety vests or hard hats. And the reason why, like, you could also do with object detection, you could try it with classification, but I'd definitely go with object detection or instant segmentation. And then a lot of times Polygon models, like instant segmentation models, might have higher accuracy than an object detection model, but there's payoffs to it as well. So, all right, so I'm going to open up my data labeler. Again, shared the link in the chat if you want to sign up there and kind of follow along. I'm going to be going through some examples, and I will give you a link to that as well if you want to download these images and kind of try to replicate what I'm doing on your own, or if you want to try it later, or you could bring in your own image on your computer and kind of try some examples there. All right, so I'm going to hit create new project. So once you verify your email, you'll be able to log in. You'll have a screen like this, and I want to hit new data set here or create new here. So I can hit new data set, and I'm just going to call this labeling demo because I'm going to put multiple things in this project. Normally, I would give this a much better name. I would say like construction PPE or something like that. But I'm going to use kind of multiple different types of images and put them on one project so it's easier for us to get through in this workshop. So I'm going to hit save and continue to sources. This is where you connect a data source. So for this example here, I'm going to upload local files. And that's why I gave you that Google Drive link. You could download those on your computer and then upload them here this way. But we also connect to Amazon S3 buckets and Google Cloud Storage. These are super common, for people that use our product here, connecting with like an S3 bucket. You might store all your data, all your images in that place, and same with the Google Cloud. But for this example, I'm going to hit upload local files. Then I'm going to hit choose my files here. And I'm going to start with, so I have in that folder that I shared, I have 3 folder types. So I'm going to go through instant segmentation and object detection labeling. That's the bounding boxes and polygons together because they're pretty similar. And then I'm going to do a separate project doing the feature points, and then I'll do a separate one doing classification. So here I'm going to go in this segmentation folder, and I'm just going to upload all of these. And again, normally when you have a data set for computer vision, you probably have hundreds of images or thousands, maybe even 1 million or something like that. And in this example, I'm just going to be showing a few because you probably don't want to stick around and watch hours of data labeling. So keep that in mind. You'll want way more than just the few samples we're going to use here. Someone asked a question, does our product work with Azure blobs? Not yet. So Azure blob is kind of similar to the Amazon S3, but it's Microsoft's version of it, and we don't currently have that in here. But I think it's probably coming. I'm not sure where it is on the roadmap. But I could get back to you on that if you want to follow with me later as well. But great question. All right, so now we upload our images. You can see the progress here. Some of them took a little bit because I think they're pretty high resolution. Now I'm going to go to label definitions. This is where we create the label types. So it's great to understand what you're trying to do first before you get to this point. So are you going to be doing object detection? Like, do you just want those bounding boxes predicted around the objects? Are you doing feature points? You will kind of want to know that right before you get to this point. So I'm going to do a few samples here. So I'm going to show labeling a goose. I'm going to show it with a rectangle. And then you can select a color. This is just for you as the labeler. It doesn't actually do anything really to your data set. But if you know the geese are on green grass and it might be hard to see a green label, I like to change it to something that's more visible. So I'll use this nice pink there. And I'll hit save. And then I'm actually going to do a goose example with a polygon as well, just to show you. So I'm going to change this to a different color just so I can know it's different. I'll hit save. And then we're going to label some cars. We're going to do that with a polygon as well. And let's get a nice visible green. And then I'm going to label cup with a polygon. Let's get a more bright color there. So this is, you give it a name, select the type. So again, rectangles for object detection, polygons for instant segmentation. You can also use instant segmentation labeling for object detection because you can calculate the square out of it. And then feature points and classification, and a few other ones we can talk about later if we want. So I'll hit save for our polygon cup. And then I'm also going to show labeling like PCB for damage. So I'm going to make a PCB one. And I'm also going to have that a polygon. And then I'm going to make a label called like PCB damage. So if you're doing something like quality assurance on a product line, this will be a little example of that. That's actually how I got into computer vision, was doing computer vision for quality assurance in manufacturing. And then I'll talk about this in a second, but we're not going to touch it right here. But you can set up some predefined classes to do auto labeling, and I'll show that off. But there's another part where it brings this up, and we'll add in the classes there. So I'll hit save. And again, I would probably have these as separate projects in real life, but just to quickly show you all here, I'm just going to include all these things in one project and go through a few examples. So once we have that, we can provide labeling instructions. This is really, really useful if you're working across a whole team, or if you're doing a really complicated projects. Like sometimes I'll add instructions in, especially if I'm doing something like feature points and there's like 47 feature points and I need to remember which one goes to what. I can actually document that here and bring it up while I label. But it's also really important if you're working with a team, if someone else is doing all the labeling, like 10 other people, you can invite them into your organization, and then they can pull up this instruction as you go. And also, even as the ML engineer, right? Like, I don't always know the best way of labeling things because you kind of need a domain expert to tell you, for example, like what a certain type of tumor is or something. If I was looking at a medical image, I wouldn't know what is what. I would need a doctor to tell me those things and document it in some way. So you can actually do that here, and even link and embed images. So you could have examples of like a good example of a labeling and a bad example, which is very useful. So I'm going to hit save and start labeling. And this will bring us to this labeler. Might take a second for these images to load. Again, some of them are high resolution. You can always resize them down at a different point in time, which I would actually maybe do. All right, so here's some geese. And so if we were labeling for object detection, we want to grab that rectangle label, right? And then we just want to draw a box around it. And you want to be pretty much as tight as possible around the actual object. But it's okay if you have a little bit of you know, a little bit of breathing room between them. Also just depends like on how accurate you want your model. Like if you're just doing kind of a hobby project and detecting cougars in your backyard or something, you know, you could have a little extra room. But if you want to increase your accuracy in production and you're actually doing this to solve like a problem and you need higher accuracy, just know that like if you had, you know, a bounding box way out here, it will not do as good of a job as if you're up as tight as possible to it. So this is what the model's actually going to look at and learn from and say, ah, these are the features you're looking for as in a goose, and then learn from what's inside this square. So if you have it really big, it might think, oh, you're looking for all the cement or something. Another important thing to note is you always want to label all the instances in your image. So if we were labeling geese for a project, and let's say we had another goose in front of us here, if I didn't label it, our model would have a hard time understanding what we're looking for, because it would say, cool, I'm learning and I made predictions that this is a goose, and that's correct. But you said this isn't a goose, again, hypothetically, if there's one here, and it would have a hard time learning the patterns we're looking for. So if you're doing things like instance segmentation labeling with polygons or object detection, you want to make sure you get all the samples in your images. An exception to that is if you had a goose really far away, right? It would be okay to maybe not label it, because you'd be like, well, I don't ever need to do detections when a goose is super far away, like it was really small back here. But if it's the size and kind of what you want to make a prediction on, you want to make sure you always label it. And then when you run a model, you could add some extra code that says, you know, only make predictions in this area. So if a goose was really small in the background, it wouldn't even look there potentially. So that would be it. Like for this image, labeling for object detection, I would just hit submit here and then keep doing that for my entire data set. And it's actually pretty easy, right? Doing object detection data labeling is not too painful. You draw these squares around it. So let's go look at a Polygon example real quick, and then we'll get into some of the kind of neat AI-powered labeling tools that will make it even faster. So Polygon labeling, if you've ever done a Polygon computer vision project before, you've probably done something like this, where you kind of draw the outline, like you want to trace where this goose is. And I'm going to do a pretty poor job here. You want to be, you know, again, as close as possible to this goose, like the actual object you're trying to detect. Going to go around, and you can see that, you know, I'm not even doing the best job here, but this is taking quite a bit of time to draw polygons for our instance segmentation. And this is why, like, a lot of people don't use them sometimes, because just training for object detection, if that's what you're doing, is so much faster. But I'll show you a really cool feature. We'll get rid of that. You can select a label, just hit back or the delete key, it'll remove it. So we have a tool called Smart Polygon. You can enable it by clicking this little button here, and then just select that label again. And then now we can draw around the goose, just like we were doing object detection. And then click, and then boom, snaps in. So it actually takes me about the same amount of time now as labeling for object detection. So if I need instant segmentation or the higher accuracy that maybe that type of model can do, you can see Smart Polygon saves a lot of time. So I'll do it here. And you'll see that it actually wasn't perfect here. And that's because, like, even with my eyes, like, I'm like, okay, this looks a lot like the sidewalk, right? So sometimes if you have very similar contrast in your data, like data object and the background, it might have a hard time picking out. It does surprisingly well, though. Like, I've used it in some stuff where I thought it wouldn't work, and it did. But the cool thing is, like, I'm almost all the way done labeling here, right? I just need to go in and I can adjust these little polygon nodes. Boop, boop, and then I'm done. So if it saves me, maybe I want to come fix this. If it saves me, like, or if it gets me 80% of the way there, it's still going to save me a ton of time versus having to do it manually. You saw I did a very poor job there, and it took so much longer than even just going in and having to adjust that one. And the cool thing too is, like, so if we wanted to, you can also highlight that little polygon node and hit the back key, and it'll delete it. So if it does put too many little nodes there, you can go in and kind of adjust everything you want here, which is super cool. So if it gets you like 80% of the way there, saves a ton of time, right? And again, I don't know if you've done polygon labeling before, but I am so excited using this every time, and it works, really well, and it's awesome. So let me show another example. Let's say that, if we had like 50 geese, this is also kind of hard to do on an image, right? It would take a lot of time. Maybe it's not hard, but it's very time consuming. So we have a feature called auto label, and this has common classes in it. So like things like cows and cars and people. And what we can do here is assign our label and use this auto label functionality to look for any of these classes. There's 81 of them in here. So it won't have everything, but it does have quite a bit. And the cool thing is, so like there isn't one for goose, right? They don't have a goose data type in here, but there is one for bird. And so we can try that out. I'm gonna hit bird, and then let's hit OK. Now it's gonna automatically look at our image and apply rectangles to where it thinks the bird is. And this also works with the polygon labeling as well. And then again, if it's not perfect, you can always come in and adjust these things. In this case, it actually did really well. But occasionally, the data might be way different than the ones that it's trained on, and it will do a prediction, and maybe it's not 100% perfect, but if it gets you almost all the way there, again, saves a ton of time. So I would just hit submit. I'm done with this image. And I'm going to turn this off. You can toggle all these features on and off here. Any questions so far? Are you excited about labeling? Are you more excited about labeling than you were when you started, hopefully? Are you going to do labeling, computer vision labeling? Let me know in the chat. All right, so let's go ahead and do, someone asked a question, how many images do I need to label for the project? So that really depends on a lot of different factors, like how much variations in your data in the real world scenario where you need to do detections is a big factor. So example, I do a workshop where we go and train a object detector with for geese, and with about 100 and something images, and there's several geese per image, it does a decent job of detecting geese in similar environments. But if you were to change to like a desert versus a green park, it might not it might not do that well. But typically, like if you're doing something in production, you might need thousands potentially of image, but it does depend a lot on your project, and also like the scope of your project, like how accurate do you need it, and how much variations is a big thing. But if you're doing something like, again, hobby or just getting started, if you have several hundred images, try labeling them, try training your model and see how well it does, and then come back and add more data in. But a lot of it really is about just getting more data a lot of the times. And I can talk about a little bit after this, I can talk about ways to make that even easier to get more data. So here, I'm going to go ahead and let's do the car polygon. I'm going to hit the smart polygon again because it's awesome. And even though drawing around the car wouldn't be too crazy here, might as well use smart poly because it's still way faster. And then, oh, sorry. So it worked well here. What I actually want to do here is demo auto label again. So I'm going to hit auto label, and I'm going to look for car class. There is a car class. I know that there's also a couple others I might want in this case. So we're looking at a highway. Maybe we're going to get trucks. Maybe we're going to get motorcycles as well. And I'm going to hit OK. And it's going to look at this image and automatically labels the car. And then, so I have several frames from the same video. So a lot of times you'll have, you're going to bring in a video data set, and you might have a ton of frames with like same cars in it. And you just don't want to spend all the time labeling it. So I turned on auto label. Again, I can toggle it on and off here, and I'm going to hit submit. It's going to look at the next image in that series from this video I took and see it automatically applied the label there, automatically applied the label there. I'm just going to keep going. Some more cars come in a second. Label, label, and then see a new car came in. Actually, 2 new cars came in, and it labeled this one well. It did not catch that this one came in. So now I can go ahead and automatically just or use a smart polygon to draw that quicker. and then let's hit submit. And then now it catches this one, and it's just going to get all the rest in the data set there. So way faster than manually drawing polygons on every single car. Oops, I should have talked that off. I see someone said a question, when automatic polygon tool doesn't work that well. Probably on data types, again, like I showed with a goose, where there really wasn't that much contrast between that part of the goose and the sidewalk. I think it's kind of things like that. But surprisingly, it's actually worked on things where I thought it might not do that well, where they have similar backgrounds. So you should try it on your data set and see if it works well or not, because I've been kind of blown away by it sometimes. And it's not the smart like polygon selection, right? It's not doing like auto label where it's looking for a specific class. It's trying to figure out what's an object or not that's within that bounding box. So it actually generalizes really, really well versus auto label where you only have those 81 specific things it can really work with. So here I'm going to show another feature. I'm going to use polygons on a cup. So again, I'm going to use smart poly because now that I have this available to me, I almost never ever want to manually draw polygons again, though you totally can. And boom, around the cup, I might clean up that bottom part. It got a little bit of the shadow there. And then I'll do it on this cup as well. Now, in the auto label, I don't know. I actually don't think there's a cup class. Let me clean this up real quick. But the cool thing is I'm going to show a feature called track forward. So if you have a whole bunch of frames from a video again, and in this case, we have 2 cups from like videos and they're segmented out into frames here, I'm going to turn on a feature called track forward. What this does is, I do these first labels in the first frame here. And then as we look at the next frame, I'll hit submit. It's going to load the new image and automatically track. So it didn't look that different, but these cups are kind of moving different angles. Like I took a video around the cups, and what it's doing is it's saying, cool, you labeled this object. Now I'm smart enough to understand that this is another frame and the same objects are inside that frame. I'm going to try to find them and automatically apply the labels. So it's not using the auto label feature here. It's actually understanding that we labeled something and then looking for a similar type object in the next frame and applying the label. And you can see it actually did really good here. It didn't even get really the shadow there too much. So let's just hit submit, the next one. And this is really cool because you're kind of just QAing at this point. If this works well on your data set, you label it, and then you're like, cool, I'm just making sure that everything is fine. And it's not going to work perfect all the time. If everything like this worked perfect all the time, then there wouldn't be a need for these kind of data annotation tools because you could do it all with AI. But a lot of times you still want to manually review. And then about like the auto label, right? Like you saw it didn't pick up the car that one time. We have a feature coming out soon that you'll actually be able to label data like this, train your own model. So if you're using a data type that's not in those 81 classes, you'll be able to train your own original model and then use it to auto label your data, which is going to be really, really awesome and super powerful because that's why you typically need to label data sets. Like you can't use a pre-trained classifier for everything because your data set's probably at a different angle or lighting than it was pre-trained on. So being able to train your own model and then tie it back into your labeler and get those labels automatically kind of applied is going to be amazing. And then just turn these off, but I would just hit submit here. And then if I wanted to label this PCB just as a manufacturing example again, I'm just going to turn on again smart polygon, even though it is just a square, so it wouldn't be too hard for me to draw. And boom, snaps to it. And then right, if I was going to label these scratches and do some sort of automated detection for this type of damage, I'm going to label this with the polygon, and this one I would just kind of probably manually draw around. I don't think smart poly would pick up these scratches very well, but we could try, especially with all these little holes. But I would label something like this and feed this into my model saying this is some sort of scratch or damage. And then you could train a model that automatically detects like a PCB and then detects these types of scratches and maybe heat maps where it is. So you as a quality assurance person, you know where it is. So I'll just hit submit on that. So once you're done labeling all of your data, What you can do is if you had someone else go label it, you could go back to your labeler. And if you go back to your labeler and you labeled all the data, you'll notice it looks empty. You can hit this pending here. By default, it goes to pending images. So because usually you're continuing labeling on a project. We can go look at submitted or look at all images. I'm going to hit submitted. So we have our 15 images. Now, if I was working as a team and someone else labeled all of these, I could go in and then like manually approve. Yeah, this looks good. This looks good to me. And if someone was way off labeling, I can hit reject and then have them relabel it. But a lot of times you don't need to do that on your own data set. So if you are doing something more as a hobby project, you can also just go to review, where you have all this data set and you don't have to manually approve them all. It's just a great feature that you're probably going to use if you're doing this professionally. But we're going to hit export. So we support pretty much all the major export formats that you'd need to use for computer vision. We have Cocoa. It's probably the most popular that most object detection kind of libraries can already just take in Cocoa data sets and know how to read those annotations. And then we have CreateML, that's Apple's, and we have our own JSON format. This is just like a kind of a generic JSON that you can do whatever you want with. So you often will build your own data loaders for computer vision projects, and you can define exactly what to look at. And I'll show what this looks like in a second. And then we have Yellow and Pascal VLC. So I'm just going to leave it at this right now. We also have this really cool feature that's very handy because almost anytime you ever do deep learning or computer vision with deep learning, you always want to have separate data sets for training and test and validation. So we make that really easy here to do. Just, you can change these numbers. By default, it's 80% train, 10% test, 10% validate. And you have some other options like randomizing the orders. And then this is important though. So if you're not going to go and approve all the annotations, you can go and hit just submitted annotations here and then hit export now. It says your export's completed, and you'll get a notification up here in a second. Sometimes the push notification I've noticed just doesn't show up right away, but if you do hit refresh, it should be there. It will come in a second, but I'm impatient right now doing it live, so I'm just going to hit refresh. Click this, download export. You'll get a zip file here. And then if you open it up, you'll have an image folder with all those images. And then you have your train, test, and validation JSON files. And I'll just open one up real quick as a preview. It's not going to be super pretty or anything. It's just going to be a very long JSON string. But you get an idea that this is all the annotations that we had for our images. So it'll kind of point to a path where the image is, and then has the coordinates of like the bounding boxes or coordinates of the polygon mask that we drew over it. And that's what you then feed into your neural network. Any questions on that so far? It was a lot to cover if you've never done data annotation before. Hopefully, if you have done data annotation, there's some cool new features you're excited about. But let me know in the chat if you have any questions about polygons or object detection labeling before I get into the feature point. Was there any features that you thought were really cool that you've never seen before? As you're hopefully typing something in the chat, I'm going to hit new data set, and I'll just make one for feature points. And we're going to kind of just show this with hands, but you could do this with a whole bunch of different stuff. So it's a polygon feature is pretty cool. Yeah, the smart polygon, I love it. Let me tell you, if you've wasted, or maybe not wasted, if you've spent hours labeling images before and you hadn't had kind of a smart polygon tool like that, it's so awesome. So I'm just uploading a few images of hands here. And then again, I'm doing a local file, and then I'm going to go to label definition. And I'll just say finger points. And then I want to hit feature points. And you get two color options here. And this is so as you're labeling, you kind of see a gradient as you label. This is kind of the way that feature points work. So let's say we're going to have 10. I'll show you why, because we're going to label the tips of fingers and then where they go back in the hand. And so you could use this to do different things like measuring poses of hands, measuring the relationship between a finger and a thumb. So let me put in 10 here. And I'll pick some distinct colors that it'll change to. You'll see how this works. So I'll go from blue to yellow. So as we label, the dots will go from blue to yellow. Again, you can put cool instructions here, but I'll hit save. And I'll save and start labeling. And here are pictures of a hand. And in this case, again, it would be important to understand like how you're going to train the model and like what you want it to do. But in this case, we're going to say that we're going to go 1, like 0.1 is going to belong to the thumb, 2, 3, 4, 5, and then we'll do a 6, 7, 8, 9, 10. And we just make sure that we do the same for all of our labeling here. And then when we feed it to the model, hopefully be able to make those predictions. So let's start with the thumb here, kind of label at the tip. And I have an article that's pretty cool if you've never done feature point models before that kind of walks you through training them. So now you'll know how to label, and then you'll be able to go label your own data and then train a model if you want. So here, I just did one hand. I would hit submit. And again, we would just do the same. Something like this. And you would just go through the rest of them. I won't do this one. We'll just pretend I did it there. And then again, you have your export options. And then you would just need to know like which ones can you use feature points with. Cocoa and then our sense JSON. Those might be the only ones that support feature point data annotation. And you would just hit export now. You'd be done. And then I'll go through real quick on the classification. If you need to label for classification, like someone talked about doing construction site PPE, one application, you could just be like, is a vest present in an image or not? Depending on how you're checking on people. And in our example here, I spelled that wrong. I'm just going to leave it. It's fine. I'm going to hit add. I'll upload a few images again. Our example is going to be pretty cute because it's dog, cat, and a bunny. And I'll go to label definitions again up here. And I'm going to title this label animal. And then we're going to give it several classes to choose from. So it's going to be called animal. I want to select classification. You can also do multi-classification. This would be, multi-classification would be if you wanted to have more than one label assigned to an image. So if you're looking for like hard hat and vest or something as a classification thing, you could do that. In our case, we're going to have only one per image. So it has to be a dog, a cat, or a bunny. So I'm going to hit classification here. And then we'll add in 3 options. I'll say dog, you type it in, and then you hit enter. I'll say cat, enter, and we'll say bunny, enter. And then you have an option to select a default option. So by default, I'm just going to have the label say dog if you don't want to select it. And then I will hit save. And now we have our animal label. Let's save and start labeling. I'll load in here. You can see here's a picture of a very, very small baby bunny. This is actually my sister's bunny had babies, and it's a really cute picture. So I'm going to hit this classification label, and I'm going to select bunny, and I'll hit submit. And then for the cat, this was my sister's cat. I was teaching it to code. You can see he's doing really good on the computer there. And I would hit submit. And then by default, the class label is dog, so I could just hit submit. But again, if you want to change it or double check, you would just open that up, hit submit. And then again, we can export our data set. Maybe we want to create a classifier with Apple's Create ML framework. And I would just, I could up this to 100, only because our data set is so small here. That's actually the only reason I'm changing it. Otherwise, I'd probably just leave it. But it's going to output them all in one folder there. And I want the submitted annotations, not just the manually approved ones. I want just anything because I didn't go through and do the approval process, which is great. You should do that if you're working with a labeling team, on a real problem probably. But if you're just working on your own, you can just hit the submitted one, and I'll hit export now. And again, because I'm impatient here, I'm just going to hit refresh. And then I have this notification. My export's available for classification. I'm going to download it. And this is the create ML format here. So I open up this folder. We can see there's a train folder in it. And then within this folder, there is several folders. So you have bunny, cat, and dog. And so what this did is actually just really puts the images in the correct folder. And that's the format that create ML expects. It's actually the format that a fair amount of kind of just built-in classification frameworks or architectures support that you can import in from common libraries like TensorFlow or PyTorch. But we also have the sense JSON version. So if you want to export as JSON and organize them that way and build a data loader for that, you can also do it that way. And so that's kind of the demo on doing object detection labeling, instance segmentation, feature points, and classification. And that's just kind of the labeling example of it. But I did want to mention real quick. So if you do want to come, I have a workshop in a couple weeks that actually goes through training a model after labeling. And this is in that workshop, we do labeling for object detection and instance segmentation, and we talk about how to train a model for those then. There's also a link here where you could just watch this as well. I'll link to it. Can't get it. So if you're looking, hey, cool, now I know how to label, and I want to go look into how to actually bring that in and train it in Python or something, that's a good place to start. So I'm gonna stop recording here, but I'll be hanging out and answer any questions you have, and then talk a little bit more about some other stuff we're doing if you're interested. So let me know, did you learn anything new?